Bright QT. Every student matters.
Now, let us study a few more things. That is, we will be asked in question as to where exactly the current is going, rather than where exactly the current, we may be given where exactly is the direction of magnetic field or the direction of force, right? We will be given to find out using Fleming's left hand rule to find out the direction of current or force or magnetic field lines, right? The Fleming's left hand rule told us about three things. One was the direction of force or motion. Second, it was the direction of current, and third, the direction of magnetic field lines. If any two are given to us, we can find the direction of the third one using Fleming's left hand rule, but for that I will tell you a few things. If you remember them, you will be able to relate the language that will be given to you in the questions. Let us see what are few important things that we need to remember. The first important thing we need to remember is that we need to know the directions. Come on sir, directions. Now we have to learn the directions also. Yes. Why and how? Let us see. We know that we have got four major directions. This is the north direction. This is the south direction. Everybody knows. Right. This is north and this is south. Everybody knows. But I have seen a few students getting confused with east and west direction. So for that, always try to remember the strategy V. This is V. Right. This V is west to east. So this is the east, this is the west direction. First thing. Now, when I am talking about west east, that is all right. But when I am talking about north and south. Now there are two possibilities of north and south. I will say north means upward direction. It is going in the upward direction. South means the downward direction. This is the downward direction, right? When I talk about upward and downward direction, the first thing comes to my mind is geographic north and geographic south, right? Okay, but what about when this particular point in three-dimensional I take, right? For example, just look at my hand. I am saying that these are basically the directions. You are able to see them as per what you are seeing. Let us see from your perspective, not mine. This is north direction, geographic north, upward. This is south direction, geographic south, downward. As per you, it is the west direction, looking at front, and as per you, this is the east direction, WE. What if the direction is shown by my finger? Now this is a three-dimensional, right? I am showing you this particular my finger direction. If something is coming like this, I'll say that it is going upwards. But when I am talking about upward, actually it meant this upward. This is geographic north, upward, geographic south. If something is coming like this, this is also upward, and if something is going inside, that is downward. But we need to differentiate between this upward and this upward. Similarly, we need to differentiate between this downward and coming towards me downwards. So for that differentiation, what we do is one upward we relate it to be geographic north, and if something is coming upward, right, in that case what we do is this upward is also represented as coming out of the paper, right? I am not talking about this north, I am talking about the way it will be coming out of the paper. Or downward, when I say there are two downwards. One is geographic south downwards, and one is when something is going inside. So that is going into the paper. When I am talking about a three-dimensional but on a piece of paper, then coming out of the paper and going into the paper, these are upward and downward directions also. This you need to remember. Got it? This is the first thing which we need to remember while doing the questions that we will be attempting after doing this topic. Now, the second thing we need to relate is quite importantly the direction of current. When we are talking about the direction of current, then in the question we will be given two type of particles. One will be protons or alpha particles, which are also represented by this sign alpha particles. These are positively charged particles. Whether it is protons or alpha particles, they are positively charged particles. And the second type of particles, of course, are our electrons, which are our negatively charged particles. Now, importantly, when we are talking about the direction of current, then while doing the questions, we will take the direction of current to be same as that of the direction of positively charged particles. That means if the protons or the alpha particles are going towards north, we will assume that the current is also going towards north. Right? If they are moving towards south, then the direction of current will be towards south. But in case of electrons, we take the direction to be exactly opposite to that of the direction of electrons. Means if the electrons are moving upward, we will take the direction of current to be downward. If the current are moving towards left, we will take the direction of current to be right. Fine. So this is very important thing that you need to remember, that the direction of current is taken to be exactly same as that of the direction of positively charged particles or protons or alpha particles, and the direction of current is always taken to be opposite to that of where exactly the electrons are moving. Clear? Fine. This is the second thing that you need to remember. Third and yet again important thing is the direction of deflection of particles. Now, I am not specifying particles here. It may be both positively charged or negatively charged, whichever are given in the question. Wherever these particles are getting deflected, fine, that direction is taken to be the direction of force, because this is where they are getting deflected, means in that direction force must have been exerted, so that will be the direction of force. Now these are a few things that you need to relate, fine, while doing the questions. Let us review the direction of current. We need to take depending upon what type of particles were given to us. The particles, if they are protons, the same direction will be the direction of current. If they are electrons, the direction is taken to be opposite to them. Talking about magnetic field lines, it always go from north to south. Directions north, south, east, west, geographic south, geographic north, upward, downward, coming out of the paper, going into the paper, we saw that. And the direction of deflection will be the direction of force. Now let us see what exactly are the type of questions we will encounter. First question that we will find is, we will be given a figure, right? The figure is given out to be like this. We are asked that this is the magnetic field. Now we know that the magnetic field lines always go to from north towards south. That means this is north, this is south. This is assumed. Now we will be given this kind of an arrow, a line, and it is labeled electron beam. Fine. Now the question states that an electron beam enters a magnetic field in direction of right angle as shown in this particular figure. What we are asked is, we are asked that calculate the direction of force which is acting on this electron beam. Now for this particular part, first of all we see what exactly are the various directions. The direction of magnetic field is quite evident that it is from north to south pole like this, right? The direction of electron beam is downwards. So as per what I have learnt, if the electrons are going in this direction, that means the current will be going in the opposite direction. Now try to relate once again my hand movement. In this hand movement, just try to relate. This is Fleming's left hand rule and we need to find the direction of force or motion. Direction of magnetic field lines is given to us, right? So I place my finger towards the direction of magnetic field lines, that is from north to south. The current is going in the upward direction. So I will try to place my middle finger in such a way that my middle finger now points towards the direction of current which is in the upward direction, keeping the forefinger once again in the direction of magnetic field lines. Now I find that the thumb is pointing towards the downward direction. That means if the thumb is going down, the force will also be in the downward direction. So that will be my answer, that the force acting on this particular so-called electron beam will be in the downward direction. And if it is an MCQ question and you are given an option that downward or into the paper, it will go inside the paper, right? In both these, any of the given option is our correct option. Got it? This is the first type of question that will be given to us, right? Let us see the second question. Let us relate. Now what he is saying is, this is a current carrying wire, this is the direction of current, right? Simple, we have been given. Now this is a magnetic field and we have said that this is south, this is north. Fine. Alright. So a current carrying wire is placed in a magnetic field like this. Direction of current is given to us. Magnetic field north to south, and we will relate that the magnetic field lines will be like this. Fine. Where will be the deflection or movement in this wire? Once again applying the left hand rule. Left hand rule, just looking at my hand, we see magnetic field lines are simply north to south, right? The current going in the right direction, my right, not yours, as per the question. Current is going towards that direction, thumb pointing towards upward, therefore this wire will move up, right? This wire is going to move. Got it? Fine. How simple these are when we know exactly the Fleming's left hand rule and exactly the direction concept. Now let us see a different question. Third part. Now question given to us is that a stream of positively charged particles, means protons or alpha particles, right? Specifying it, alpha particles, is moving towards this stream, alpha particles is moving towards the west direction and is deflected towards north by a magnetic field. Now we are asked the direction of magnetic field will be, what will be the direction of magnetic field? Now try to relate what all exactly is given to us in the question. A stream of positively charged or alpha particles is moving towards west. If it is moving towards west, that means the current is going towards west. Right? The current is going towards west because we have seen that the direction of current is, we are going to take the direction of current to the direction of alpha particles or the positively charged particles. Right? Current is going towards west as per north, south, west, east. It is deflected towards north, and wherever is the direction of deflection, we say that it is the direction of force and the force is towards north. Now we need to calculate direction of magnetic field lines. Once again, looking at my hand and trying to relate the Fleming's left hand rule. See, this is Fleming's left hand rule. He stated that forefinger, middle finger and the thumb to be placed in perpendicular to each other. What we are given is that the current is going towards west. This finger, middle finger, is pointing towards current that is going towards west. Right? Your west or my west, I am taking at the moment my west as per what the figure I have made. So this is the west direction that I am taking. Right? The current is going towards west, my west. Right? And in that case, the force is in the upward direction towards north. So the magnetic field lines are going upward. And if this was the geographic north upward, so now our concept will be applicable that this magnetic field lines by upward, I mean to say coming out of the paper. Are you able to relate that this is the geographic north that we have said? So if this is upward direction and this is also upward, if this is north, that means this will be coming out of the paper. So the direction of magnetic field lines will be upwards, and we need to relate and specify this upward, that is coming out of the paper. Got it? Fine? Right? Good. Let us see a next question. In this question, we are going to be solving this question. Think you are sitting. Just think you are sitting in a chamber. Any particular chamber you are sitting with your back to one wall. Like there is a wall on your back. Fine. Now an electron beam. Right. An electron beam is moving horizontally from back wall towards the front wall. That means the electron beam is coming from your back side and going towards the front wall and is deflected. It is deflected towards your right by a strong magnetic field. It is deflected by a strong magnetic field towards your right. Now we need to calculate, find the direction of, we need to calculate the direction of the magnetic field. Right? Try to relate the question. Just look at me. Right? I am sitting, fine, with a wall at my back. Now in the question it has been specified that a electron beam is coming from my back side and going towards the front wall, and I know that the direction of current is taken opposite to the direction of electrons. So if the current or the electrons are related, electrons are going from back to front, therefore I will relate that the current direction is from the front wall towards me, towards the back wall. Fine. For finding the magnetic field, of course we need to relate the Fleming's left hand rule once again. Every time the left hand rule is getting used, right? So if I am talking about the direction of current which is coming from the front wall to the back wall, I will place the middle finger denoting the current towards my side. Got it? So this is the first thing that I related and that I had placed in the direction of current based on the opposite to the direction of electrons. Now the second part I have been told is that this electron beam is deflected towards my right. If I am talking about me, I and you are exactly opposite at the moment, right? So you need to just come my way imagining it. So I am just telling you as per my side. So it is deflected to my right side, and I have told that wherever the deflection is, that means the force is acting on that side. So if the deflection is towards my right side, this force, the thumb, I will be moving towards the right side, keeping this current part towards me only, right? You are able to relate? So current is towards me, the force is towards my right side because the deflection is here. Now my forefinger will point towards the direction of magnetic field, which at the moment is pointing downwards. So the direction of magnetic field will be downwards. How we are able to reach this particular point, I hope you are able to relate. Got it? Fine. So this is the application of what all we did till now. Let us take one last question based on this. It is a very good question. Now we are given a particular figure. This is once again being told to us as a labeling that this is the direction of magnetic field, right? Now this is a line and we are having the labeling charged particle. Now let us see what exactly the question is saying to us. The question says that a charged particle, what type of charge is on the particle we don't know. A charged particle enters a magnetic field at right angles shown above, right? This is at a right angle shown above. Fine. In a uniform magnetic field, the parallel lines show the uniform magnetic field. What we are asked is, what is the nature of the charged particle? What is the nature of the charged particle? Means, is it a positively charged particle or a negatively charged particle? What is the nature of this charged particle if it begins to move in a direction? Now the movement is specified that if it begins to move in a direction vertically out of the paper due to interaction with the magnetic field. Due to interaction with the magnetic field. Now, try to relate the question, students. First thing, very simple, we got from the figure itself that the magnetic field is in this direction, that means this is north to south. So I get the figure that I get the position of my forefinger. Now the question says that a charged particle is going into this particular magnetic field like this, right? When it moves, right, when it goes into the magnetic field, under the effect of the magnetic field lines and the force of it, it will deflect and it begins to move in a direction vertically out of the paper. Now, if it is moving out of the paper, that means it is the direction of force or the direction of motion being provided to us, right? Now what we will do is, we know the direction of magnetic field, we know the direction of motion, we will find the direction of current using Fleming's left hand rule. Now if the direction of current is same as that of this direction of charged particle, so we will apply our basic knowledge that this charged particle would be a positively charged particle because the direction of current and direction of positively charged particles are taken to be same. But if using Fleming's left hand rule, we find that the direction of current is going opposite to this direction of charged particle, then we can easily comprehend that this charged particle is a negatively charged particle or an electron. Why? Because the direction of current and electron are opposite. So let us apply this particular Fleming's left hand rule once again. Fleming's left hand rule, what it said was, place the thumb and the forefinger and the middle finger perpendicular to each other, right? Forefinger represent direction of magnetic field, current is represented by middle finger and the force represented by thumb, right? Now I just place my fingers as per what is given in the question. It is being asked that this is north to south. Fine. So I have placed my forefinger in north to south. Got it? And the charged particle is coming out of the paper. That means the direction of force, thumb, is going to be in the upward direction. And applying this, I relate that my middle finger is pointing towards me. That means if I relate, this is pointing in the same direction as that of the charged particle. Therefore, because the direction of current here is also same to that of the direction of charged particle, I will say that this is a positively charged particle. Got it? Right? So for doing these type of questions, again I want you to go back and I want you to relate these three concepts. The concept of directions, the concept of direction of current. If it is protons, the same direction is to be related. If it is electrons, then the direction of current and electrons are taken to be opposite. And the direction of force, wherever the charged particles, whether it is negatively charged or positively charged, they are getting deflected, the same is going to be considered to be the direction of force or motion. By relating these, you will be able to relate all the questions. Fine. I hope you have studied and understood whatever I have told you till now, consisting of electric motor, Fleming's left hand rule and its applications. Try to relate them, try to learn them, and please try to make electric motor and practice it because that is also important, the diagrams and the labelings.